Okay, so let's look at homework problem 9-59. So it says a ball is thrown horizontally with a speed. The first thing I want to do is I want to draw my picture because my sign convention is important. So I'm going to draw a giant dot for where motion begins. So here it says a ball is thrown horizontally with a speed of 15 meters per second. So V naught is 15 meters per second. From the top of a building, 25 meters high. So I'm measuring the building from here down. So when I write my given, this y is going to be negative 25. So right away, why don't I go ahead and write my given? Remember, I'm going to separate my x and y given. So I'm always going to say that ax is 0 and g is negative 9.8 meters per second squared. Why am I going to do that? Because when we're doing the problems in two-dimensional kinematics, we're using the same equations as one-dimensional kinematics that have 4 variables. So if we know 3, we can find a 4th, and this is just going to remind us of those other ones. Now the key to this type of horizontal launch is this vector is all horizontal. It has no vertical component. So in my given, I'm going to write V naught x is equal to 15. And V naught y is equal to 0. And the last thing they gave us is y is equal to negative 25 meters. Now, what you're going to see here is, how do I know where to start? Well, over here, I have 3 things. So wherever I have 3 things, I know that's going to help me. That's where I'm going to want to start. So let me read the rest of the question. So it says A, how far from the base of the building does the projectile strike the ground? And I should have finished my picture like that. So that's going to be x. And then B, determine the speed of the projectile at impact. So I want to find VF. Now, I'm going to draw it to the side because I ended up writing there. The VF is going to be like this. And what that means is the VF has both a horizontal and vertical component, and that's why we learned how to do vector resolution. So this is VFY, and this is VFX. But we're not finding that now anyway. So let's start with A. How far from the base of the cliff? Now, how far from the base of the cliff is X? So that means I have to do stuff here on the X side, but I don't have 3 things. So then I'm going to say, well, what's the common factor on both sides? And that's t. So I can use this information to find t. And once I find t here, that's going to be equal to t here. So I know, what am I going to do? I have little g, I have v naught y, I have y, and I want to find t. So I'm going to write my basic equation. Y is equal to v naught yt plus 1/2 gt squared. V naught y is 0, so that whole term disappears. So I end up with y is equal to 1/2 gt squared. I want to solve for t, so I'm going to rearrange the equation to solve for the unknown terms in the known. So t is equal to the square root of 2y over g. If I do this, I'm less likely to make a mistake. I'm not going to forget to take that square root at the end. So t is equal to the square root of 2 times negative 25 meters divided by negative 9.8 meters per second squared. When I do all this, t comes out to be 2.26 seconds. Now, let's say I want to make sure I didn't make an algebra mistake. So remember, my units check my work. We have a foolproof way to check our work in physics. So underneath the radical, I have a meter divided by a meter per second squared, which is a meter times a second squared over a meter. So this meter cancels with that, and I end up with second squared under the radical. So when I take the square root of the number, I take the square root of the unit, and I end up with seconds, which is the correct unit for time. What are we finding here? Now we want to find x. So x is equal to, I know x is equal to v naught x plus 1/2 axt squared. And ax is 0. Why did I bother writing this? Because I'm not memorizing all new equations for projectile motion. These are the same equations I used for one-dimensional. I'm just applying them vertically or horizontally. So don't think, oh, what's that projectile equation? It's the same equations. So if you want, you can just write it the way you remember and then say, oh, I know ax is always 0. So this is equal to v naught x, which is 15 meters per second, times time, which is 2.26 seconds, and v naught x comes out to be 33.9 meters. But let's go ahead and look at our units. This second cancels with that second, and I end up with meters, which is the correct unit. All right, let's look at part B. So for part B, remember, your final velocity, and they just asked for the speed. If they asked for the velocity, we would have to find both the magnitude and the direction. But they only asked for the speed, so we just care about the magnitude. We don't care about the direction. So first of all, we know that VFX is equal to V naught x, which is equal to 15, because the horizontal component of the velocity is constant because there's no horizontal acceleration. To find VFY, we can use one of our equations. So there's actually more than one way to do it. I could use the equation VFY is equal to V naught y plus GT, but when I do this, what I'm doing is I'm using, or we can use the equation VFY squared is equal to V naught y squared plus 2GY. The reason I'm not doing this is I'm using the answer here that I found here. Can I do that? Absolutely. But let's say I think, what if I got the time wrong? If you have time, you can do it two ways and check your work. So now I'm going to substitute in my values. VFY is equal to the square root, this is 0, of 2GY, which is equal to the square root of 2 times negative 9.8 meters per second squared over negative 25 meters. The two negatives in the under the radical, a negative times a negative is a positive, so I have a positive underneath the radical, which I have. And then I have meter squared over second squared, so when I take the square root of the number, I take the square root of the unit, and I end up with meters per second, which is the correct unit for velocity. So VFY comes out to be 22.1 meters per second. But I'm not done, because I want to find VF. So my components are, again, perpendicular, head to tail. So I want to find the resultant, so I'm going to use the Pythagorean theorem. So VF is equal to the square root of VFX squared plus VFY squared. So that's equal to the square root of 15 meters per second squared plus 22.1 meters per second squared. So VF ends up being 26.7 meters per second. So that's my final speed of the projectile. So this is the horizontal launch. And again, this is easy because our initial velocity is just all horizontal and it has no vertical component.